Let's take a look at making a grid inventory with the ability to swap items around. Alright, so what you're seeing on screen here is I just have a little sprite here. This is a character body 2D, and it's just something for me to essentially put my inventory on. Not that big of a deal. And down here, I'm just using obviously a canvas layer because this would be a UI element. So it only makes sense. We may as well just stick it in the canvas now, right? Because you're going to do that with your normal games anyway. Now I'm using a color rect for my background here. You can of course use something like a 9 patch if you wanted to and have all your slots displayed with some kind of texture going on back there. It's completely up to you. Now the actual inventory portion where we show all of our items is contained within this grid container that we're using. And for this I have my max columns set to 12, and with code we are going to limit this. So we got 12 columns of 3 rows, giving us a total of 36 slots. From what I saw in Stardew, there's some pictures. This is about what you have in there and your little backpack as well. So this is what we're going with. You can of course change the maximum, change the columns and all that to suit yourself. And for my grid container, you can see over in the inspector, in the theme overrides, constant, H separation, and vertical separation. I'm using 70 on both of those. And my sprites that I'm using here is 64 by 64. So if you're using a different resolution, then obviously you're going to have to change and tweak all these numbers to suit yourself and your projects. All right. So first things up, let's take a look at how to create some of these things. So we're going to need 2 additional scenes here. And all these that you see in here is just purely for example purposes, demo purposes. All these will be removed once the game actually runs. But for now, we're going to use a ghost icon that we see here. And that scene is just going to be a sprite 2D. It's going to have a script that only has the 1 line of code in it. And I've made it semi-transparent, about 50% transparency, and that is how we get this transparent look here, which if we actually come back here to our scene, you can see it better when I click on something. As you see, now we have this visual representation for the player that we are dragging something around or moving it around. Alright, so we just have that scene again. I'm just calling it a ghost. It's just a sprite 2D, about 50% transparency, and I'm doing that with self-modulate. And the script that is on it is just inside of the process function. We are setting its global position equal to our mouse's global position. So it's nothing complicated. And that's just so that when we're moving it, it's going to stick with our mouse so we know where we're moving it to. Alright, and next we have our display item. And this is the actual item that's going to show up visually inside of our inventory. So this is just a control node to hold on to everything together. And it has a label with its alignment to the right, the horizontal. And I've just gone ahead and added an outline onto this text just to make it easier to read, since I have a light background. And we'll use that label to display the amount of said item that we have. And I have a texture rect here, which is just going to display the texture of the item that we have. Alright. Now this texture rect does have 2 signals, mouse entered and mouse exited, and they're both connected to the script that is on our display item. Alright. Now the code for our display item here we have a variable called mouse in. This is a Boolean. This is either, of course, going to be true or false. It is going to be false by default. And what this is going to do is it's going to let us know whether our mouse is inside or outside of our texture rect area. And you might be questioning, well, if you're using the mouse entered and mouse exited signals, why do we need this? Well, we're using this to determine some of our conditions later. And the mouse entered and mouse exited signals are basically turning this true and false. Next, we have a static variable on our display item here. This is called moving. It is a Boolean. It is false by default. Sorry there. And this is going to determine when we are actually moving an item or when we want to swap positions between two different objects. Now, you might have noticed this is a static variable, and you might be wondering what a static variable is if you haven't seen one of the older videos on the channel. And a static variable essentially is going to sync this variable value with all other items of the same. So when we add all these display items, right, all of these different items inside of our grid container, if one of these changes moving from false to true, then it is set to true for all of them. And if it's set to false, it is set to false for all of them. And that's because they're all coming from the same scene. So static is forcing them basically all to share one value instead of letting them have their individual values. Okay. And then we have two custom signals, move and swap. And those are just gonna pass in an index when we send the signal. Alright, so as I said earlier, our mouse entered and mouse exit is just gonna change our variable from true to false. And other than that, we're using the input function, and we're using underscore event here because we're not actually going to use the event property or the event argument that gets passed in. Just putting an underscore there ignores it in the debugger, so we don't get the warning pop up saying, hey, this isn't being used. So with this, we have essentially two conditions. So if we're mouse in, right? So if our mouse is inside of our display area and we're not moving and we left click, then we're going to turn moving to true and we're going to emit our move signal. And get index is what that's effectively going to do is it's going to look at its parent and look at itself, and it's going to find what its child index is, right? So if it's index 1, it's going to send 1. If it's index 6, it's going to send 6. So it's going to get that and send that with the signal. All right. Now, else if our mouse is hovering over another object and we are moving and we left click, then we're going to set moving to false and we're going to emit our swap signal and send our index with it. Now, these are going to be two different indexes because remember, you're going to click on one object, right? And that's the one that you're going to want to move. You're going to get the index from that object. And then the second object is what's going to trigger when we get to this. Because remember, moving is going to be true for everything once it's set true because it's a static variable. So the second object that we click on is where this swap signal is going to come from. And therefore, that index is going to be passed in from the second object we clicked. So if this is object index 6, right, child 6, and we click on child 0, then we're going to have 0 passed in here and 6 passed in here. Hopefully that makes sense. And we'll handle those signals. They're going to be connected up to our grid container, which we'll get to momentarily. But at this point, we actually we're going to need items to swap around. All right, so we're going to go ahead and create a script that's extending our resource. The class name is an item, and we have some exported variables here. And this is going to be a display texture. That way we know what image to show inside of our grid. We're going to have an amount, which is an integer. That way we can show how many of that item we have. We're going to have a name because you might want to use that name for comparisons, which we will be using later on. And you might want, maybe you want to display the name in some way. You can do that as well. We have a variable of whether or not the object is stackable. And in this case, stackable is kind of going to be like a default situation, I guess, that we can put here. Whereas the items you wouldn't want stackable would maybe be a key item, which you should only be giving a user once anyway. And then our last value is how many of that item can be stacked up. So this will allow us to have maybe one super common item can stack up to 99, and then maybe some other rare item you're limiting to a stack of 10 if you wanted to. So you have that option. Alright, now if you haven't seen our resources video in the past, once you've created this resource, right, this item, you can now right click into your file system and you can select new resource, and you'll be able to select an item resource. And if I just double click on my apple here, you can see over in the inspector, once you've opened it, you're going to see all of those exported objects, right? So you're going to see a spot for your texture, a spot for the amount, which I just set it to 1 because obviously if you're getting one, you're probably going to have 1 to start with, right? It doesn't make sense to really pass in 1 automatically, but maybe you will. We have a name, stackable, and my max stack is set to 99. All right. So now we have an item. We need an inventory to stick that in. So with that, I'm extending a resource again and creating my inventory class. And that is going to have 2 variables and a signal. We're going to have an exported one called slots with a capital S here. And this is going to be an array, but we're also going to typecast it to only hold item. Remember, item is the resource class that we just created. So only items can go inside of this inventory. I have a max set of slots. I've set this to 36. Again, we're using 12 columns, so that's going to give us 3 rows, just like we have a Stardew. And we have a custom signal here called update display, which will have an argument of slots, which is anything we pass in there has to be an array of items. Now, update display is what we're going to use to actually update the grid that we're looking at, and that the player would be looking at in-game. And this inventory is going to have just one function called add item. It has one argument of an item that gets passed in. Of course, it has to be from the item class. And this is how we're going to add things to... We're basically just managing our array from here. So when we add item, if slot size is greater than or equal to our max slots, then I'm just going to print out inventory full, and we're going to exit out of our function, right? Because we have a full inventory, we can't add any more items to it. All right, so now we check if item is stackable, right? If item.stackable, then the first thing we're going to do is we're going to run a for loop, and we're going to look through our slots, right? And we're going to see if the item, which is what we passed in, we're going to see if that name matches i.name. And remember, I is representing the item that's already inside of our inventory, right? Inside of our array. So we're seeing if there is a match. Basically, we're checking if this item is already in one of our slots. Then we're going to run a check and say if that amount of that item is already at our max stack, then we're just going to return. We're not going to add any more to it, right? Because that's already full. And if it's not at max stack, then we're going to run into our block down here, which is going to increase the amount +1. And we're going to emit our signal of update display and pass in our updated slots array and return out of it because we don't want to add things multiple times. Now, if the item is stackable, but we're not running into this for loop, right? Or none of this is true, rather, I should say, which means the item is stackable, but we do not have one of these items in any of our slots yet in our array. Then we're going to go ahead and we'll just append it into our array, append our new item, and I'll emit our signal update display and pass in again our new set of slots, our new inventory. And then we have our else block down here, which is just covering if we try to add an item that's not stackable. In which case, we'll again add the new item, emit our signal. Alright, so that's all our add item has to do. And now we can handle items that are stackable, not stackable, determine if we can carry any more of that item, or if we can carry any more items, period. If we can carry any more of that specific item, which in your case you might want to make, maybe you make a second entry to handle this. In my case, I'm not doing that, but maybe that's something that you want to set up. And for the most part, that just leaves us now with our last two scripts. So the actual grid container that's going to show our items, and my player. So I'm going to go to my player first. And that's just because it's going to be a much shorter display, or much shorter code here. So for my player, I'm doing export a variable called inventory. And this is going to be from the inventory class. So that's going to allow me to click on player, go over to my inventory from the drop down and select a new inventory for us here. And on ready, I'm just going to get my grid container. I just called it GC. Now you can, of course, call it whatever you want. Display inventory, inventory grid, display grid, right? Whatever you wanted to call it. And I'm only doing two things in here. Inside of my ready function, I'm connecting my inventory. Right, connect my inventory signal, update display. I'm connecting it to my grid container, right? The thing that's actually going to be showing the objects. And I've connected that to a signal I'm calling update display with a lowercase u. Right, now the rest of this here is just adding items into the inventory for what you saw in the beginning. So in this case, I'm just running through 400 times, adding 400 apples, which showed you that the apple does stack. It stacks up to the maximum, and that's it. Anything past that is not added into the inventory. And then I showed you again here a few more bananas, as well as the Godot item. And I created this function called getItem just because it would be nicer to, when you want to add something, just say player, getItem, or player, giveItem, player, receive item, whatever you wanted to call it, and just pass the item in. Instead of going player.inventory.addItem and then pass an item. Alright. And the item that we're passing in order to load in our resource that we created based on our item class, all we have to do is just load that resource, and we don't need this as item here on the end. It would be just fine without it, but just as a little bit of safety check to make sure that it's not loading in some weird way as something else, I'm just making sure that's loaded as an item when it loads up. And that just leaves us with my grid container. Now here we have a variable for player, and you'll notice here this says %player, and that's because if you right click on your player you can actually access or set a unique access to it, which allows us to do this. So in this case, I can just do %player. Instead of going get parent, get parent, get parent, and then come down to get child or get node player, right? Or get node and going through root, node, player, right? Instead of going through all of that, I can just have this set up here. Much easier to access. Of course, you can always just export a character 2D and pull the player into it. That would work too. And the only other variable we're going to need here is going to be my swap item index. Okay. Now, update display. So this is coming from our signal being emitted from our inventory. Remember, whenever that changes, we call update display. And the first thing that's going to do is we're going to run through this for loop and just remove all the items out. And then we're going to run through our slots. So we're creating a variable called slots with a capital S. And remember, slots being passed in as a lowercase s for the argument. So we're going to take that lowercase s slots and we're going to call filter. And we shouldn't have to do this, but just in case there's any weird issues, I'm going to filter this out. And this is a lambda function. And all we're really doing here is this is a one-off function. And we're basically saying if the item inside of our array is not equal to null, right? So we don't have like some kind of empty entry in there somehow, then we're going to return that item. That's going to ensure that this variable only has items inside of it. And we're not going to have some kind of weird null object that has somehow been appended. Alright, so again, you shouldn't need that line, but just for a little extra safety, I threw it in there. Alright, and then we can run through our a for loop to go through all of those items now. So for S in slots, and that's slots with a capital S in this case now, we're going to create a variable called new item. I'm going to load an instance of my display item scene that we created. I'm going to add that item as a child to my grid container. I'm going to connect that move and swap signal. And you can see I'm connecting them to a function called initiate move and initiate swap. And then on my new item, I'm getting child 0, which is our texture rect. And I'm setting the texture of it to the display texture of the item that is inside our array. And likewise, then getting the label, setting the text property, and setting that to a string of the amount that we have. Alright, so to initiate the move, we have an index that gets passed in. And we're creating a variable here called ghost, where we load in an instance of that ghost scene, which remember is just a sprite 2D that has half transparency. We're going to get parent and add child, so we're basically just going to be adding it into our color rect at this point, since we're only going up one level. I probably should just go up to canvas layer, but it doesn't really matter. And we're going to set the texture of our ghost to our player.inventory.slots. And we're going to pass in the index that we got from our move signal. So we can get the item that we're initially trying to move, and we're grabbing the display texture of that item. That way we can have our ghost item be a transparent version of whatever it is that we clicked on. Then I'm going to set the swap item index equal to that index that we had passed in. That way we can reference that when we actually create or actually perform the swap, which is what we're doing next, our initiate swap function that we connected to our swap signal, which also has another index passed in. So I'm going to create a variable for a temporary item from the item class. And we're basically going to get the player inventory slots and passing that swap item index. So we can see that first item that we clicked on. So we're making a temporary item that is a clone of that. And then we're going to go into our inventory slots and we're going to get that swap item index. Right, so that first item that we clicked on is now going to be replaced with the new item, right? The second item that we clicked on. So we're taking, again, if we refer back to this, if this was index 6, we're going to set index 6 now to be the same as, say, index 1. Right? So now at this point, once this line is completed, index 1 and index 6 would be the same item. And then we're going to go to that index 1, and we're going to set that to our temporary item, which, remember, is basically a clone of that index 6. So now we've effectively swapped 6 and 1. Or swap the items of index 6 and 1. Right, and then we can call in update display and then pass in our player inventory slots. And once that's been updated, we can get our child, we can get 0 because it doesn't matter. This is a static variable, remember, moving, and we're setting that to false, which really it should be false anyway, since update display completely erases everything and puts a new set in there. So theoretically, we shouldn't need this line in here at all. But I've got in just for just a little extra safety precaution, just to avoid any issues. And then we're basically just gonna free and delete up the ghost that we had. All right. So if we go back and take a look, we have our items that get updated and added in. And if we click on our Godot icon here, right? So we've clicked on index 2. We now have a ghost that has copied the texture from that index. And if I click on the apple, that apple is going to, or that is now going to initiate the swap, right? By sending out that swap signal and passing the apple's index. I just move this over a bit. So this index 2 from our Godot icon is, just 1 second here. Swap out, yeah, is what's going to be passed in. Or I'm sorry, it's been set to our swap item index. So index 2 here is going to be copied into being this temporary item as soon as I click on the apple. And then the apple, which is index 0, that is being passed in. Right? If we look at it, what we're going to do is we're going to set index 2 here. This first item I clicked on, that is being a ghost, is going to have the same item as our apple, right? Index 0 that I'm going to click on. And then we're going to take that temporary item that we've cached temporarily, and we're going to copy that over to index 0 here. And that goes so quick that it looks like they just completely swap places. All right. Hopefully that wasn't too confusing. And you can see we can go to any of these slots here, doesn't matter. And these slots don't exist. If you wanted to extend it to have empty slots, you could. That's just completely up to you. That's your choice, but hopefully that's not too confusing. And I see we've run on to roughly a half hour, but hopefully you guys understood that. Take care. Have yourselves a good one. And I'll see you guys in the next one.